Hello, this is a important question of chemical equilibrium, and it says that 0.02 gram of selenium vapors at equilibrium occupying a volume of 2.463 ml at 1 atmosphere and 27 degrees centigrade. The selenium is in state of equilibrium according to these reactions. So we can see that in this reaction there is a association happening. So for such question we find the degree of association. Now one thing that we have to understand is that this is the mass 0.020 gram is a mass of selenium vapor, and that is a equilibrium of Se2 and Se6. Let's see how we solve this question. So the given equilibrium is like this in the vapor state. Let us assume that initial number of moles of selenium is n. Note, we cannot find that by dividing 0.02 by twice into 79. No, because that 0.02 gram is a mixture of both Se2 and Se6. Right? Therefore, it cannot be used. So let us say the initial number of moles of pure Se2 is n. So initial number of mole is n. At equilibrium, let us say the degree of dissociation, or in this case is become, because the molecules are associating, so the same factor becomes degree of association, right? So if I say x fraction dissociate out of 1 mole, therefore out of n moles it will be n minus nx, which I am writing like this. Okay, now the dissociation of Se2 is nx. We can see from here that 3 moles of Se2 combines to give us 1 mole of Se6. It is 1/3. Therefore, if this nx is n into x, that much amount of moles of Se2 is associating, it will give 1/3 of that number of moles of Se6 molecule. So it becomes nx upon 3. So what is the total number of moles at equilibrium? So you will add n into 1 minus x plus nx by 3. So that becomes equal to n in bracket 1 minus 2x by 3. In rough, we can find the molecular weight of selenium vapor Se2, that is twice into 79, which is 158. Also, we try to find the molecular mass of the mixture, and that is from the data. This has to be calculated from data, right? So we can use the ideal gas equation. PV is equal to N. N is nothing but weight upon molecular weight into R into T. This W is the weight of what? The weight of the equilibrium mixture of Se2 and Se6, which is given as 0.020. So putting the value in place of W 0.020, R 0.0821, temperature 27 degrees 300 Kelvin upon pressure 1 atmosphere into volume 2.463 10 raised to power minus 3, that becomes equal to 200. That is the molecular mass of the mixture. Now we know that the total mass is conserved because a part of selenium Se2 was converting into Se6, therefore the total mass is conserved. So we can say from the conservation of mass, we can say that initial number of moles into initial molecular weight is equal to final number of moles into final molecular weight. N into m is nothing but the mass or weight. Okay, so initial number of moles was n, and the molecular weight was entirely Se2, so that is 158. At equilibrium, number of moles, you can see that on dissociation number of moles increases, on association number of moles are decreasing, right? So n in bracket 1 minus 2x upon 3 into the molecular weight of mixture, which we have found out to be 200. On solving, we get x is equal to 0.315. So we can say from here that for this question, answer should be B.